So in any electrical circuit, there are always three main parameters: voltage, which is measured in volts, current, measured in amps, and resistance, measured in ohms. 1. For a better understanding, just think of a water tower. The height of the water level can be seen as the voltage, the width of the spout as the current, and a valve as resistance. A German physicist named Georg Simon Ohm found that these parameters had a fixed relationship, which is now called Ohm's law. 3. Knowing Ohm's law is essential for designing devices that run on electricity. Now let's talk about oscillating circuit. 4. An oscillating circuit is basically an energy storage device, and it works like this. Initially, a capacitor is fully charged and has a certain amount of electrical energy in it. 5. When you close the circuit, the current starts increasing, and as the capacitor discharges, the coil's magnetic field grows. 6. At some point, the capacitor is completely empty, meaning it has given all its energy to the coil. 7. At this moment, the voltage on the capacitor is 0 and the current in the circuit and the coil's magnetic field are at their maximum. 8. All the energy from the capacitor's electricity has been converted into the coil's magnetic energy, which is 1/4 of the period. 9. Next, the stored energy in the coil is used to recharge the capacitor. The coil's current recharges the capacitor, decreasing from its maximum value to 0. 10. When the magnetic field in the coil is gone, and the capacitor is fully charged again, but the positive potential of the capacitor is now on the lower plate, we've completed half of the cycle. 11. The cycle then repeats in a similar manner, and this process will continue cyclically until it fully decays. 12. Let's save the concept of circuit quality factor for later. 13. You can pump or maintain energy in a circuit in two ways. Either with a voltage source, which makes it a series circuit where high voltage oscillates, or with a magnetic field source. 14. This type of circuit is called a parallel circuit, and it's where the current reaches higher values. 15. So if your 12-15-year-old son is interested in electricity, some of this info in the video might be helpful to him. 16. If you found this interesting, please leave a comment below.